Okay, this is Dr. Paul Farrow from GradeMakers.com, and today we're going to talk about functions. And what is a function? Well, a function is a relation in which no two different ordered pairs have the same x-coordinate or first component. That's a very complicated way of saying that basically they act just like machines. So if you put an input into the machine, and by input I mean a value of x, then we get a desired output. You can see on the right hand side that we have an example of a function machine. This particular function is f of x equals 5x plus 3. So if we set the x value to 4, we see that we first have to do 5 times x, so 5 times 4 is 20, then we add 3, and that gives us our f of x, our function of x, which in this case would be 23. Now we can graph functions by plotting their x value against the f of x value. In other words, the input versus the output. In this case, we've graphed the function of f of x equals 5x plus 3, which we got from the previous slide. And we do this in order to look or inspect how the function behaves. For this function, we can see it's a linear function. We often want to know things about the function, like where do those functions cross the y or x axes of the graph. And we can do that by inspection, so we can simply look at where the line of the function crosses the x or y axis, or we can do it algebraically. To determine where the function crosses the x-axis algebraically, we would set the y value, or the f of x, equal to 0. And then we substitute that into our equation, and we have 0 equals 5x plus 3. Then we subtract 3 from both sides, which leaves minus 3 equals 5x. Then if we divide both sides by 5, we have x equals minus 3/5, or x equals minus 0.6, which is just the fraction or decimal form of the same thing, which tells us that the function crosses the x-axis where x equals minus 0.6, and of course f of x will equal 0. So the coordinates of the point where the function crosses the x-axis are minus 0.6, 0.